Good morning, good evening, and good afternoon for our examiners, judges, and audiences who watch this video. My name is Alexander with my friend Ernesto Revan Yogantara Arjuna, and we are from SMA College Indonesia Jakarta. Today, we would like to discuss about the result of our experiment, and our topics is the effectiveness of acetone, methanol, octane, and acetic acid solution in dissolving styrofoam with reaction byproducts as an alternative to paraffin wax. The first thing will appear at your mind is why styrofoam. First of all, waste is a problem that we often find in big cities like Jakarta, and styrofoam is one of the common waste that we can find. Styrofoam itself is classified to difficult to decompose because it takes hundreds and thousands of years to be naturally destroyed. Apart from that, styrofoam also requires chlorofluorocarbon or CFC in the manufacturing process, where this substance is dangerous for the ozone layer in the atmosphere and for everyday human life. Styrofoam also contains dangerous chemicals such as benzene and styrene, where human cannot digest it. Through this study, we would like to uncover some options to dissolve styrofoam through different chemical solutions. We would like to utilize the byproducts from the chemical reaction as an alternative to paraffin wax candles. Then we go to the research methodology, where it's divided into two stages. The first one is the chemical reaction between the solution with styrofoam, and the second one is the use of this reaction byproduct as an alternative to paraffin wax. We go to the first stage. Every solution was filled into test tubes containing 10, 15, and 20 millimeters each. In total, 45 millimeter of every solution within 3 samples. Second one, place 1.5 to 2 grams of styrofoam at the test tubes and observe and document the chemical reaction for about 2 minutes. The second stage, we prepare some 20 millimeter aluminum paraffin wax molds to place the byproducts of each reaction result. There will be 3 different samples. The first one, the full paraffin mold. The second one, combination of paraffin and the byproducts. And the last one is a mold with only the byproduct. Thanks, Revan.
Thank you very much, Terry. I will now, first of all, talk about the styrofoam dissolving ability. For the four chemical solutions that we tested, we found that acetone and octane actually reacted to the styrofoam, in which acetone succeeded to dissolve the styrofoam into a byproduct, meanwhile octane fully dissolved the styrofoam within a 5-minute time span. Other than that, the acetic acid did not produce any reaction, and the methanol only changed the color of the styrofoam. From the two graphs below, we can see the duration of the acetone's reaction and also duration of the octane's reaction, where acetone 1, acetone 2, and acetone 3 had a time range of 5 seconds up until around 13 seconds, and the octane had a time span of a little under 60 seconds up until 70 to 75 seconds. If we move over to the top right, we can see some documentation and some photos on the experiment, where acetone, you can see the byproduct. The methanol, we can see that the styrofoam changed color to blue. The octane is slowly dissolving the styrofoam, and the acetic acid did not produce any reaction. Second, the styrofoam reaction duration. We found that the higher volume of solution corresponds towards the time reaction. From the graph, we can see that both acetone 3 and octane 3 has reduced time if we compare it to acetone 1 and acetone 2, or if we compare octane 3 to octane 1 and octane 2. This is because acetone 3 has 20 milliliters and acetone 1 and 2 have 10 and 15 each, and octane 3 has 20 milliliters as well, and octane 1 and octane 2 also each has 10 and 15 milliliters. And finally, for the candle experiment, we found that the samples containing ordinary paraffin is the most effective because it has the longest duration. The candle with acetone byproduct and mixed with the paraffin has a huge flame size. Meanwhile, the experiment with only the acetone byproduct, A1 and A2, created a black smoke, generated burnt smell, and also left behind a black residue. This is most likely due to the properties of acetone being highly flammable. If we move over to the table on the right, we can see the total data. Meanwhile, do note that the sample of P3 was prematurely blown up because of sudden gust of wind. Next slide. Finally, we get to the conclusion. where methanol and acetic acid had little effect. Meanwhile, the octane dissolved the styrofoam and acetone created a byproduct. We found that the higher volume corresponds with the time spent as well, where 20 milliliters have the shortest reaction time when compared to 10 milliliters or 15 milliliters. And acetone's reaction time is also faster if we compare it to octane. And thirdly, we found that the byproduct of acetone is not an effective alternative because it has significantly lower fire duration. It created black smoke and black residue. This study also has its limitations because the minimal amount of samples gathered, so it would be better if we had more data samples and did the experiment in a more controlled area so that external factors such as wind or human disturbance did not happen. Next slide. And we finally get to the references. This is our references. This is all from us. Thank you very much for watching our presentation. My name is Revan and my friend Terry would like to sign off. Thank you.